Pokemon Math Professor back one more time for one more video related to systems of equations. Now in this particular case, we're going to be looking at parallel and perpendicular lines. This is something you might have got introduced to in 8th grade when you were first sort of looking at slope-intercept form and lines and things like that and how they behaved on graphs. You might have looked at the idea of parallel and perpendicular lines. So let's look at parallel. Do you remember what that means? That's right, it's lines that never intersect. So on the graph, how do we know if lines never intersect? Well, here is our guide. Here's our sort of definition or rule that we can follow to know whether or not lines are parallel on a graph. Parallel lines will always have the same slope. They'll have different y-intercepts, but they will definitely have the same slope. Knowing that, knowing how to find the slope of a line parallel, then all you need is one other point on that line, and you should be able to find the equation in slope-intercept form for that parallel line. Let's take a look at that. So I have a point, 3, -1, and I want to find the line parallel to y equals 1/3 x minus 3. So the first thing I need is the slope. Well, the slope of the parallel line is going to be the same as the slope of our current line. And since the slope of our current line is 1/3, that's the slope of our parallel line as well. From here, I decided to use the slope-intercept form to find my y-intercept. So this is one method you can use. It's not the only method, but it is one. In order to find the y-intercept using this method, I need to take that point and plug it into the equation. So in place of y, I put a -1, and in place of x, I put a 3. And now I have to simplify and solve for my y-intercept. 1/3 times 3, well, that's going to give me a value of 1. -1 equals 1 plus b. To solve for b, I need to subtract 1 from both sides, and I get that -2 equals b. Now that I have my y-intercept, I can put it back into my equation to get a final answer of y equals 1/3 x minus 2. This is the equation of the line parallel that goes through the point 3, -1. Now what about perpendicular? Do you remember that one? Perpendicular lines are lines that intersect at a 90-degree angle. Okay, these are very specific. No other angle measure, it has to be 90 degrees. Well, it turns out that if you begin to look at perpendicular lines on a graph, you begin to notice that there is something in common with their slopes as well. Perpendicular lines have slopes that are opposite and reciprocal of each other. Opposite meaning positive, negative. Reciprocal is when you take a fraction and you flip it over. So perpendicular lines have opposite reciprocal slopes. Again, once you get the slope, you can use any of the methods that you may know for finding the y-intercept for the corresponding perpendicular line. And then we're going to finally put that equation into slope-intercept form. So let's take a look at this example. I have the point -2, 2, and I want to know what line goes through there and is perpendicular to y equals 2/3 x plus 2. First thing I need to do is get that slope. Now, slopes are opposite reciprocals, so it's the opposite of my slope. My slope is 2/3. It's a positive number, so my perpendicular slope is going to be the opposite or negative. And it's also the reciprocal, so I take the fraction 2/3 and I have to flip it over. And when I flip it over, I get a fraction of 3/2. So my perpendicular slope is going to be -3/2. Now for this example, I decided to use the point slope form to help me get the y-intercept. And in the point slope form, all I need is a slope and a point, which I have, and I just have to put it in there. So I go y minus 2 because the y coordinate of my point is a 2 equals negative 3/2 times the quantity x plus 2. Why x plus 2? Well, because the x coordinate of my point is a negative 2, and minus a negative makes positive, or x plus 2. Now, the first step, I got to distribute. Take that negative 3/2 and multiply it to both the x and the 2. When I do that, I get y minus 2 equals negative 3/2 x minus 3. Because negative 3/2 times 2 would make negative 6/2, and when I simplify, that makes negative 3. Now, one of the reasons I like this method is because now, after distributing, I only have one step left. I just need to get the minus 2 on the left side over to the right side, and I'll be done. So I use the addition property of quality to add 2 to both sides, and I get y equals negative 3/2 x minus 1. So, in this video, I showed you how to find slopes for perpendicular and parallel lines. I showed you two different methods, one using slope-intercept form and one using point slope form, to find that parallel or perpendicular line. So really the key here, because you've already found slope-intercept forms in various different ways through the first part of algebra, then understanding those slopes and keeping the rules handy so that you can use them quickly, or just sort of coming up with some way to remember the rules for the slopes of parallel and perpendicular lines, is going to be the key to finding their equations. Everything else, the actual solving for the equation, you've done multiple times, and that's probably pretty solid at this point. Thanks again to Slides Go for helping me with my slides.